Before this video ends, a star somewhere in the universe will explode. A black hole will swallow light itself, and the universe will become bigger. Right now, as you are listening to this, space is expanding, not galaxies moving through space. Space itself stretching in every direction at once. And the most unsettling part is this: we do not know why. You feel like you are sitting still, calm, stable. But you are not still. The Earth beneath you is spinning at roughly 1,670 kilometers per hour. At the same time, it is orbiting the Sun at 107,000 kilometers per hour. And the Sun itself is orbiting the center of our galaxy at more than 800,000 kilometers per hour, which means something incredible. You have never been in the same place twice, not once. Every second, you are millions of kilometers away from where you just were. You are traveling through the universe at unimaginable speed, and you cannot even feel it. When you look at the night sky, you are not seeing the present, you are seeing the past. Some of the stars above you no longer exist. Their light began its journey hundreds, thousands, sometimes millions of years ago. By the time that light reaches your eyes, the star that created it may already be gone. Every glance upward is a glimpse into history. You are looking back in time. The universe itself is about 13.8 billion years old. That number is almost impossible to understand. So let's shrink it. Imagine the entire history of the universe compressed into a single calendar year. The Big Bang happens at midnight on January 1st. Galaxies form, stars ignite, planets are born, and then for almost the entire year, there is nothing human. No cities, no language, no civilization. Humans appear at 11:59 and 56 seconds on December 31st. All of recorded history, the pyramids, the Roman Empire, every war, every invention, every love story, all of it happens in the final seconds before midnight. Cosmically speaking, we arrived just now. And yet, in this tiny fraction of time, we figured out how to measure the age of the universe, how to detect invisible matter, how to look billions of years into the past. For most of cosmic history, the universe was silent. No eyes, no questions. Now, for a brief moment, it can observe itself through us. The sun feels warm, peaceful, reliable. But the sun is not a gentle fire. It is a controlled explosion. Every single second, about 600 million tons of hydrogen are being crushed together under extreme pressure. Those atoms fuse into helium, and in that fusion, a small amount of mass is converted directly into energy. That tiny loss of mass powers the entire solar system. In 1 second, the sun releases more energy than humanity has produced in all of its history combined. And it has been doing this for billions of years. But nothing in the universe lasts forever. In about 5 billion years, the sun will begin to run out of hydrogen fuel. Gravity will start to win, the core will collapse, the outer layers will expand, the sun will grow into a red giant. It will become so large that it may swallow Mercury, it may swallow Venus. The oceans on Earth will boil away. The atmosphere will be stripped into space. Every trace of life will vanish, not in an explosion, but in slow, unstoppable heat. And yet, time itself is not as simple as we think. We experience time as steady, 1 second after another. But time can stretch, time can slow down. If you move fast enough, time passes more slowly for you than for someone standing still. Astronauts orbiting Earth age slightly slower than people on the surface. The difference is tiny, but it is real. Gravity can slow time too. The stronger the gravity, the slower time flows. Near extremely massive objects like neutron stars or black holes, time begins to distort dramatically. There are places in the universe where 1 hour for someone near a black hole could equal years for someone far away. Time is not universal. It bends, it stretches, it flows differently depending on where you are. The universe is not just stranger than we imagine, it is stranger than we are capable of imagining. At the center of our galaxy, there is something invisible, something massive, something that does not emit light. A supermassive black hole. It contains the mass of millions of suns compressed into a region smaller than our solar system. Black holes are not cosmic vacuum cleaners. They do not roam through space, pulling everything toward them. If our sun were magically replaced by a black hole of equal mass, Earth would continue orbiting almost exactly as it does now. But if you get too close, everything changes. Gravity becomes overwhelming. Space itself curves inward. Light bends. Time slows. As you approach the edge, called the event horizon, escape becomes impossible. not because something is pulling you harder, but because space itself is falling inward faster than light can travel outward. If you fell toward a black hole, your feet would feel a stronger gravitational pull than your head. You would not explode instantly. You would stretch, longer, thinner, until you became a stream of atoms. This process has a name: spaghettification. To a distant observer, you would appear to slow down as you approach the edge. You would seem frozen in time, your image fading slowly, turning redder and dimmer. From your perspective, you would cross the boundary without noticing anything special at that exact moment. But beyond that point, all paths lead inward. At the center, there may be something called a singularity, a point where density becomes infinite, where our equations break, where our understanding ends. Black holes are not just objects, they are boundaries, places where reality as we know it stops making sense. And yet, they are everywhere. Almost every large galaxy has one at its center. Silent, invisible, waiting. Everything you have ever seen in the universe, every star, every planet, every glowing galaxy, every cloud of cosmic dust, adds up to only about 5% of reality. 5%. That means 95% of the universe is invisible to us. About 27% is something called dark matter. We cannot see it, we cannot touch it. It does not emit light, it does not reflect light, it does not absorb light. And yet, we know it is there. Galaxies spin far too quickly. If visible matter were all that existed, those galaxies would tear themselves apart. Stars would fly outward into space, but they don't. Something unseen is holding them together, an invisible gravitational scaffold, dark matter. We do not know what it is made of. We have built detectors deep underground, far from interference. We have watched the motion of galaxies. We have mapped its influence, but we still do not know what it truly is. And then there is something even stranger: dark energy. If gravity pulls things together, dark energy pushes everything apart. In the late 1990s, astronomers discovered that the expansion of the universe is not slowing down, it is accelerating. Galaxies are moving away from each other faster and faster over time. Space itself is being stretched. Imagine dots drawn on a balloon. As the balloon inflates, every dot moves away from every other dot, not because they are moving across the surface, but because the surface itself is expanding. That is our universe. And the force driving that expansion makes up about 68% of everything. We have a name for it: dark energy. But naming something is not the same as understanding it. Most of reality is unknown, and we are only beginning to realize how much we do not know. The atoms in your body are ancient. The carbon in your cells was forged inside massive stars billions of years ago. The oxygen you breathe was created in stellar cores. The iron in your blood was born in violent supernova explosions. When massive stars die, they do not disappear quietly. They explode, scattering heavy elements across space. Over time, gravity gathers that material into new stars, new planets, and eventually life. You are not separate from the universe. You are made of it. Recycled stardust, rearranged into something that can think, that can wonder, that can ask questions. There are neutron stars so dense that a single teaspoon of their material would weigh billions of tons. There are planets drifting through space alone, never orbiting a star, wandering in endless darkness. There are storms on distant worlds larger than Earth that have been raging for centuries. There are regions of space so empty that light can travel for millions of years without meeting another galaxy. And then there is the future. Trillions of years from now, stars will burn out. Galaxies will drift beyond each other's horizons. The night sky will grow darker. Black holes will slowly evaporate over unimaginable spans of time. The universe will not end in fire. It will not end in a sudden collapse. It will fade, slowly, quietly, into cold darkness. And yet, right now, in this brief window of cosmic history, you are alive. In a universe that has existed for billions of years, you are here during the short era when stars still shine. For most of its existence, the universe had no observers, no awareness, no thoughts. Now, for a moment through you, it can look back at itself. The next time you look at the night sky, remember this: you are not small, you are rare. You are conscious matter in a vast, expanding cosmos. And that may be the most extraordinary fact of all. When massive stars die, some of them do not become black holes. They collapse into something almost as extreme: a neutron star. Imagine taking the mass of our sun and compressing it into a sphere only about 20 kilometers wide. That is a neutron star. The atoms inside are crushed so tightly that electrons and protons merge together, forming pure neutrons, matter in its most compressed form. A single teaspoon of neutron star material would weigh billions of tons on Earth. Billions. If you drop that teaspoon onto our planet, it would punch straight through the surface, through the mantle, through the core, and out the other side. Neutron stars spin incredibly fast. Some rotate hundreds of times per second. They beam radiation into space like cosmic lighthouses. If that beam sweeps past Earth, we detect it as a pulse, a pulsar. Perfect, precise, more accurate than atomic clocks. The universe builds objects so dense, so powerful, that they challenge everything we think we understand about matter. And yet, these extreme objects are not rare. They are scattered across galaxies, silent remnants of ancient stellar deaths. Now imagine something even stranger. What if our universe is not the only one? Some theories in physics suggest that what we call the Big Bang may not have been the beginning of everything. It may have been the beginning of our universe. In models of cosmic inflation, space may continuously expand, creating new regions with different physical conditions, different laws, different constants, entire universes forming like bubbles in a vast cosmic ocean. This idea is called the multiverse. In some versions, there could be infinite universes. If space is truly infinite and matter rearranges in every possible way, then somewhere out there could be another galaxy identical to ours, another solar system, another Earth, another version of you, making slightly different choices, living a slightly different life. It sounds like science fiction, but mathematically, it emerges from serious attempts to understand how our universe began. We do not know if the multiverse is real. We may never be able to test it. But the fact that physics even allows such a possibility reveals something profound. Reality may be far bigger than we can observe, far bigger than we can imagine, and we are only beginning to explore its edges. There is a place in the universe where sound cannot travel, not because it is quiet, but because there is no air, no atmosphere, no medium to carry vibration. Space is completely silent. If you were floating between the stars and a massive explosion happened nearby, you would see the flash, you would see the debris, but you would hear nothing. Total silence. The universe is not loud. It is visually violent and acoustically empty, and yet there is a kind of echo still traveling through space, a faint afterglow from the birth of everything. About 13.8 billion years ago, the universe was hot, dense, blindingly bright. As it expanded and cooled, light was finally able to travel freely. That ancient light is still out there. We can detect it, a faint microwave glow coming from every direction in the sky. It is called the cosmic microwave background. It is the oldest light we can see, a baby picture of the universe. When we measure it, we are not just studying space, we are studying the moment when everything began. The temperature variations in that glow are tiny, but they reveal something incredible. The seeds of all galaxies, all stars, all planets, including Earth, including you. Before there were galaxies, before there were stars, before there was anything familiar, there was energy, expanding, cooling, evolving. And somehow from that simple beginning came complexity, came structure, came life, came consciousness. The universe began as light, and now that same universe is looking back at its own origin through your eyes. And maybe the strangest thing of all, the universe does not need to exist. The constants of physics, the strength of gravity, the charge of the electron, if they were even slightly different, stars would never form, galaxies would never gather, chemistry would never work, life would never begin. The fact that the universe allows complexity, allows structure, allows awareness, is extraordinarily fragile. And yet, against impossible odds, here you are, a thinking fragment of the cosmos, alive in the brief era when the stars still shine.